Start. Okay. All right. So let me just mute as I just joined. Welcome. So if you are having any communication, just drop it on the platform, please, so that. All right. So for those who are just joining, welcome. All right. So I want to believe my screen is sharing right now. So yeah. Great. So we have looked at a couple of things before we had that momentary interruption. All right. So there is one very aspect of a model when you're considering a linear model, a particular parameter that you will always need. For those who are into research, you're familiar with the R square parameter, which is always needed. So how do you get the R square parameter? So the first thing you want to look at is, okay, let's call it R squared. So you want the R squared parameter from this particular model. So you want to look at the summary of the model. The summary of the model. And then from the summary of the model, you want to locate the arrow, I think it's arrow dot squared or something. Let me try and confirm that. Okay, I think it's arrow dot squared. All right, so let's run this. Good, perfect. So if you want to look at this now, you come here and run this. So this is the arrow square of the model, which is 75, meaning that this model explains 75% of the data. All right, it means that this model explains 75% of the data. So let's look at the summary of the data of the model itself. Let's just run this summary of the model itself. You'll see a couple of the other things beside that, and I will explain how how some of these things, what they mean. The ones that I'm able to explain, of course. Okay, so for just ease of understanding, the estimated, these are the estimates, all right? You already saw what 37 is the intercept, meaning that if you had weight of 0, this will be the default. Okay, let me blow this up and show you here. If you have weight of 0, meaning if the weight of the cars is 0, this will be the minimum value of miles per gallon. All right, but as the weight increases, the miles per gallon reduces. Okay, so that's what this is explaining to us. So from the equation, so the equation would look like this. The equation would look like this: MPG, all right, equals to, for a normal linear regression equation, MPG equals to the intercept. Remember, fundamentally it is Y equals to C plus MX, all right? Where M there, let me run that in the comments, where C is the intercept, all right? And then M is slope, all right? So as far as what we're working on right here is concerned, MPG is our Y, the C is the intercept, and from here, what is your intercept here? Intercept is 37, let's just say 0.3, 37.3 plus, what is our M? Our M is our slope. It's not going to be plus this time around. It's going to be minus 5.3. And then what will be your X? Your X will be your weight. So this is the equation that we try to generate from our linear regression. So this equation is the equation of this line that represents the data. But you want another parameter, not just this equation. How well does this equation represent this data set? It represents it by 75%. And that is what this R squared will interpret to you. All right. There's another one called adjusted R squared. You can read more about all this. But talking about significance, okay, there's a measure of significance. How significant is this 37? How significant is this -5? All right. And significance is trying to tell you, okay, should we accept, I don't want to go very deep into null, the hypothesis thing in statistics, but significance is telling us that you need to ignore the null hypothesis, all right, and embrace the alternative hypothesis. Okay, if that makes sense at all for those who are not who have not gone deep into statistics. So the null hypothesis is the background assumption that the linear model will not fit. That is the null hypothesis. But when you are done with what you're working on and you now find something different, meaning that this thing is appearing to fit, how are you sure this is appearing to fit? You use what you call a p-value, all right? And if your p-value is very, very significant, you say you are ignoring the null hypothesis and you are embracing the alternative hypothesis, all right? So that is what you have here. So these stars here are a measure of significance. They are telling us that this intercept is very significant and the weight itself also is very significant. Is that okay? I mean, that is more like the very, very high, that is the all right. So let me give you maybe it's the network. How is it now? Is it still very bad or is better now? Just confirm, please. Let's be sure. Okay, okay.
You know.
All right, all right. Thank you very much indeed. All right. Okay. So if you have any questions, please just ask your questions right now. This aspect is very critical. This is where it starts getting very interesting. Yeah, so the same way you have worked with, remember, we are not trying to actually do data science here. We're trying to show you how R can help you. That's the reason why we are limiting what we are working on just how to use the tools that you have in R, okay? You can try to research more. There are other modeling tools. There is logistic regression. When the data does not follow a linear path, there's just logistic regression way of modeling. There are other tools also. There are some you call principal component analysis, PCA. You can do all of those in R here, using R Studio. You can do a whole lot of things. Directing my conversation to those who are into research now. Just for you to know how those tools are used, there are a lot of examples out there. You can ask Google, questions, but before you know it, it becomes part of you. By and large, this is what you get from R, essentially. Okay. So while I'm waiting, do we have any questions? Do we have any questions at all? Do we have any questions while we are waiting? I want to show you a particular data set and see uh, how we can model a couple of things from it. So if you have any questions, please drop it on the platform. Or if you need to speak, just message me so that I can unmute you. If you have a question and you need to, or raise up your hand. Yeah, there is a raising up of hand gesture there. You need to speak so that I can unmute you. So let me just stop this sharing. I have a document I want to show us. Okay, just open it. It's on Excel. It's one very big data set. Okay, so let me just share my screen right now. I want to show us a particular data set. So if you can see my screen right now, so this is a student data set. It's a publicly available data, but something that one can use to play around, okay? Okay, one can really use this to play around and, you know, work on and be able to get something. We did not really work on logistic regression here in this course because we didn't mean to actually take too much time in this course. We are also very careful to just show you what R can do. Then if you're really interested, remember more than 100 and almost 180 persons registered for this course, but you should look at the calls now, only very few persons. It means that it's not really that they are not interested, but they found out along the way that maybe this is not useful to me, all right? Okay, so as you can see, this data has the name of school, the sex, the age of the student, more like a high school data or something, and then the address, that may not be that useful, the farm size. There is an explainer data set that tells us about this. I have that somewhere. I think parent status or something. All of these have names, all right? M job, okay, mother's job, father's job, reason of something, guardian, who is your guardian, travel time to school, I think, study time of the student, how many failures, schools up, you know, all kind of information that are here. All right. So in the end, we want to be able to use all or a few of these data sets. Remember, I said all or a few of these data sets to be able to model what the grade of the student will be. Simple as that. So that means there are some aspects. There are some aspects of this. There are some particular variables in the whole of this variable that is affecting the student's grade more than the others. All right. There are some variables here that affect the student's grade more than the others, and those are the things we are going to look at. Okay. I have actually solved this some time ago. So instead of running through the code and running it step by step, I'm going to show you a solution script just to run through and to enable you to see what Arrow can do if you're working on this yourself. All right. So maybe later on, if you're interested, I will also share that particular script with you separately so that you can just try things out and see how it goes. I think that's a better way rather than just going through it here because we don't have all the time. We don't have all the time. So I worked on this a time ago. So let me just let me share with you the solution. Where's the Zoom here? Let me share with you the solution. Okay. All right. I want to believe you can see my screen right away. All right. So what is this? So this is more like the solution to that particular data that I show you just now. So let's read about this a little bit, more like an introduction to that data. So this data approach student achievement in secondary education of 2 Portuguese schools. The data attributes include student grades, demography, social, and school-related features, and it was collected by using school report and questionnaires. 2 data sets are provided regarding the performance in 2 distinct subjects, maths and Portuguese. The one we have is the one for maths. Here we provide you with only the one for mathematics. So the 2 data sets were modeled under binary 5-level classification and regression tasks. Important note, the target attribute G3 has a strong correlation with attributes G2 and G1. Of course, grade 1 and grade 2 has a strong correlation with grade 3. So these occurs because grade 3 is the final year grade issued at the third period, while grade 1 and grade 2 corresponds to the first and second period grades. It is more difficult to predict grade 3 without grade 2 and grade 1, but such prediction is much more useful. Meaning, if you are able to get a prediction of grade 3 without really relying on grade 2 and grade 1, then that is what we really want to achieve. Okay, so everything you see here, I did this about 3 years or 4 years ago. I just had to bring it up as one of the projects we have to do, but the platform we are using, coupled with the issue of network yesterday, has really dealt with us. So for that reason, I'm just going to be showing you wherever you see hash, it's either it's a comment or a result of a line of code that was run. All right. So in this case, I'll show you line by line. This particular line of code highlighted was where I read in that CSV that you saw. Okay, I read it using this run read CSV code, and then including this parameter here, it comes out, and then once it comes out, that is that. So what I did here was to split the data frame. So I splitted the data frame into the 2 parts. This 33 here, this is the y-axis. Can you hear me? Let's see if you can hear me. This is very important. Can you hear me, please? Please drop a message. What does it call? Kika, can you hear me? Just drop a message on the call, if you can hear me. Mr. Fayemi, Mr. Fayemi, can you hear me? Oh, when did Hi, about now? Hello? Is it okay now? Okay. I hope every other person can hear me, please. All right. So sorry about that. Thank God thank God I had to do a check there. All right. So if you can see my screen, so we separated the data. The data has 33 different columns, so we separated the data. So the 33 here, you can see, is the 33 here, as you can see, is the dependent variable, and then the x is the 1 to I think 32, which is G1 and G2. Remember, we said G1 and G2 are highly correlated with G3, but we just decided to add it at the initial stage. So if we try to check the data, you use this function head to check the first 5 or first 6 data points in a data frame, okay? So that you don't just show all of them. So you just use this head. All right, so we have this. So here we are trying to, let's have a summary of which is the seventh one there. 1, 2, 3, 4, 5, 6, 7. Maybe the 7th one. So we just want to see a summary. And this is how you do summary. You see the minimum value, you see the maximum value, you see the third quartile, you see the first quartile. Of course, the mean is the second quarter. So what we now do here, now pay attention, you realize that not all the data points has, what's it called, are numbers, all right? So we needed to convert, all right? These ones that are not numbers, we needed to convert them to what you call factors in R. We needed to convert them to what you call what? Factors in R. So despite them not being numbers, when we convert them to factors, the model will be able to work with them. For example, in this reason, for example, if we have course, other, and home, just these three, when we convert them to factor, this column we have maybe course will be represented by 1. This 1 is not number in this case. Other will be represented by maybe 3, and then home will be represented by 2. So these are actually factors which this model we have to work with, all right, to be able to generate results eventually. Remember, it's actually different from numbers, numeric that are manipulatable. Factors are just a way to assign numbers to particular groups, all right? So how you assign factors is very simple. This is how we assign factors. So here we've picked the particular columns one by one and assigned factors to all of them. Look at the one for sex. We assign factors to sex. Okay, what are the levels in the data itself? These are the levels you are going to get in the data. And then label this level 0 and 1. So female will be 0, male will be 1. All right? The same way we go ahead with the next one, address. There are 2 addresses, R and U. Label them as 0 and 1. The ones that have more than 2 come to job. Here you have 1, 2, 3, 4, 5. All right, so you assign labels of 0 to 4 to that, and so on and so forth. We're able to assign factor to as many of them as possible, except the numeric ones. The ones that are numeric, we left them as numeric. Now, there are some that appears to be like numbers. They are showing as numbers here. However, they are not really numbers. All right, so we needed to convert them to what's it called now, to factors again. All right, but for those particular ones, look at what we did here to show that they are in an order of importance. All right, to show that 5 is more important than 1, to show that these things are arranged in order of importance, we included this particular option here, meaning that ordered is true. All right, so don't just, in this other one, it can either be 1 or 2. They are not, there's really no order to it in particular. But for this, order is actually true. So you can say that 5 is more important than 1, or 1 is less important than 5, okay? That's why we added this here, all right? So eventually, we move ahead. We also did some other conversions here and there. And finally, we got here where we started developing the model. See how we develop models that have more than 1 variable. See how we develop models that have more than 1 variable. So you have the dependent variable already as y. Remember, at the very top here, this is the dependent variable. This was the G3. If you saw the Excel sheet I displayed the other time, this is the G3. And then the other ones, you are modeling the other ones against that. All right. So you have the school column, you have all of them. You itemize them here. separate, adding them together, this, up to the last one. And after that, you put the data that you are using, all right, the data that you have all of these columns in. So the model runs successfully, and here is the summary of the model. When you summarize the model, this is the model you're summarizing, it brings out this. The intercept, all right, we have 10 more minutes by Zoom. Fortunately, this thing is running so fast. All right, so the intercept here is minus 1.3, intercept of the model. These are all their respective coefficients. These are all the respective coefficients, but that is not as interesting as we want to see. So let's look here. Which of these are actually significant? Okay, look at the way, look at this assignment. So you can see that these three here, 1, 2, 3, they are very significant. Whether a student is absent in class or not will determine what the student gets in their final grade. Of course, we've been told earlier that G1 and G2 are very significant, all right? Another one that is significant is this family relationship or something, very significant. And looking at this significant code, this one again is significant, okay? What's the other one? Okay, age is also significant as far as this is concerned. So normally we're supposed to, okay, look at the R squared here. R squared is showing 84%, meaning that if you combine all of this together, we will be able to get 80. The model that this will give us will be, it will be explaining G3 for us 84% of the time, all right? We'll be explaining G3. So we decided to take all the important ones, and we model them together. Remember, just see, we have only age, activities, farm real, and then G1 and G2. We included G1 and G2 because we've been told already that it strongly correlates. All right. So when we do this and we look at the significance, now for you to know how important these four are, if all the models, using all of the variables, we're able to get, what's it now? 84%, 0.84 R squared. When we remove them and use only this 1, 2, 3, 4, 5, 6, only this 6, we're getting 83%. Are you seeing that now? That is trying to tell us that these 6, they are giving us 83% information. So you are removing all of this, majority of this, and you're leaving it with just 6, and this 6 is giving us this. All right. So we went further. So we detected here that, okay, which one again now? We decided activity here is not that important compared to the rest. So we remove activity and did another model. All right, trying to fine tune the model and see, because model, we just want to know that, okay, if we are predicting for G3, which is the final grade, what are the most important things that will determine the final grade? We're trying to say the job of your parent does not really matter, all right, on what final grade you come up with. And a lot of other things that does not matter. But we know that age might matter, family relationship might matter. At this third level of modeling, whether you are absent or present in school might matter. And again, what you earn in your first semesters, is it first grade or whatever now? And then second test will actually matter, what you get in your final grade. So when we did this, we realized that, okay, we're able to get 83%. So we went further to, which one did we remove now? Did we remove any? We have age, family relationship, and absence. So we removed age. We removed age to see what happens to the model. When we remove age, we're able to still get 83, but that means age again might not be a factor that much. So because the difference is very negligible when we remove age, all right? And at this point, you are beginning to see that the significance of grade 1 has actually reduced. The significance of grade 1 has reduced. And, so when you now check the correlation, between, when you check the correlation between all these, you are able to see how correlated they are. G2 is correlated to G1 by 85%. Yeah. So They are very, very important, as you can see. All right, so we now have to perform one more model, model 5. Since G2 and G1 are correlated, why should you use two of them? It doesn't make sense. You are using just one of them. They are well correlated. All right. Oh, hello. Is it okay now? Oh, so sorry about that. So sorry about the audio stuff. This is what we get some of these times. Is it okay now? Hello, can you hear me? Audio is back. Okay, it's okay. So, as I was saying before the audio went off, so essentially, I'm happy we're able to get this out. So this will be the end of this course. But in case you are interested in joining the masterclass, I'm going to announce that very shortly. It's going to be at a cost. So what we're going to be doing in the masterclass is no longer this elementary aspect. No, we have already dealt with this. So what we're going to be doing in the masterclass will be essentially to look at practical examples and data. We are going to be looking at real world data like this. We're going to repeat this itself in our example in the master class. And there's another very interesting data we're going to be looking at as well again. Maybe a few ones like that. And then if you have your own data as a researcher, we'll also look at it together and work on it and see what we are able to come up with.